In the previous video, we learned how to incorporate Objective-C code into our Swift projects. In this video, we're going to take a look at how to convert C types to Swift types and what it takes to incorporate traditional C code into our Swift projects. There are a few things to keep in mind when working with C, particularly when working with C's types. C has numerous types for scalars such as booleans, characters, and numbers. These types can be of different widths, as C offers 32 and 64-bit integers. Swift scalar types will not automatically convert to C's types. For example, a C int and a Swift int are not equivalent, so when passing values to a C function, we need to either use an int32 or a C int. Fortunately, the Swift team thought of this and provided C equivalent types in Swift. I'll make this chart available to you on this video's resource page. As we saw in Section 3, we can also use C pointers in Swift. Pointers are a notorious pain point for developers and one of the biggest sources of bugs, which is why the Swift team abstracted pointer and memory management away from the developer. Remember, Swift is a safe language. That said, Swift does provide a way for developers to interoperate with C pointers, which is by using the generic unsafe pointer types as shown here. Of course, you can find more details on how Swift interoperates with C on this video's resource page. Let's move on to an example. Create a new Xcode project, and let's create an OS X console application. Choose a name, and select Next, and then Create. The first thing we'll need is to add a new C file. With your root directory selected, press Command-N and create a new file. Select C file and press Next. I'll name my file Math and click Next, and then Create. When the application asks if you'd like to create a bridging header, select Create Bridging Header. We'll start with a C header file named math.h. This is where we declare the functions that we'll be implementing in C. We'll add two functions, one named multiply and one named square. The xturn keyword tells the compiler that this data is defined somewhere and will be connected with the linker. Then we have our return type, followed by our function name and parameters. Let's move on to our .c file. We'll implement the two functions that we just declared in our header file. We'll name the first function multiply, which takes two ints, x and y, multiply them, and then returns a single int. Our second function, named square, takes an int, squares it using C's pow function, and then returns the product. Finally, we'll configure the bridging header, which couldn't be more straightforward. Just add an include statement and include your header file, math.h. Now let's go ahead and call these functions from Swift. In main.swift, let's create a constant named val that's of type int32 and give it a value. Then we'll create another value named output and set it equal to our square method, and we'll pass in our value. Let's print our output with a simple message and build. And we see our values have been squared by our C code and printed to the console. Let's add our multiply function to the mix. We'll pass in our value and the output from our last C function call. We'll update our print statement with our new constant name and build. Again, we see our expected output. This is excellent. You now have the ability to interoperate with powerfully fast C-based libraries. Let's go find a simple C program on GitHub. Navigate to github.com and we'll search for Obfuscated Game of Life. This is the project we're looking for. It's Sean Murray's contest submission for the International Obfuscated C Code Contest, where he submitted a brilliantly obfuscated version of Game of Life. Click on his life.c file, and we see some wildly difficult to read C code. We'll borrow his code for this exercise, and while we're at it, we'll make sure we star his repository. Now, we could make a brand new C file and a new bridging header for this, but I'll just add it to our existing files for brevity. I'll change the name of this program to Game of Life and switch the return type to void. And then we'll add a reference to our header file. we'll comment out our code in main and make a simple call to Game of Life and run our program. And we see Game of Life carried out in our console. In this video, we have successfully bridged C code with our Swift code. In the next video, we'll discuss C++ interoperability with Swift.